Okay, hello, welcome to a coding session where I will have 1 hour to get as much as possible from this state to compiling a test file like this into a simple LLVM code file. So basically it should be like this. This test.c file should become test.ll file, but interesting. Okay, but it should become LLVM bytecode. Not bytecode, but LLVM code. Yeah, something like this. So, let's try to compile that. So first of all, how do we parse that? I want to avoid doing manual parsing as much as possible, so I will be lazy. I will use Translator for this. Translator and Translator C. And now let's do something actually useful, and we want to run this like this. And then we want to take a look at the file. So let's do that. So let's get the arguments. That should be something like this. And then let's do this. So yeah. Argument. We can print the argument, and we see that we have two arguments: the name of the binary as the zeros argument, and then the argument that we have. So yeah, we should skip. Yeah, actually, we can do it like this. Skip one. Well, I can even inline this usage. Okay, now when we have an argument, what do we do? If arg ends with .c, then it's a C file to compile. Yeah. So how do we convert it into pass buff? Do we do it like this? Okay, yeah, good. Now so we want to compile it into file with extension .ll. Okay, then we want to open this file. Okay, maybe it's a premature optimization. Let's not do that. So we want to open this file in path, and we want to parse it. So to do that, we need to set up a Translator parser and actually parse it. So how do we do that? Translator C, language. Okay, now I need to take a look at the docs. So I have to use Translator parser. Okay, parse language comes from twitter C, and then parser set language into, and then I can parse. Okay. So, twitter parser new parser set language twitter C language. Right. What is expected here? Language FN. Oh, okay, yeah. I remember something like this. Okay. Cannot borrow. Okay. Okay, it must be mutable. Yep. And then I can parse an old tree, which should be known, and some text. And that will give me a twitter tree. Okay, so now we have to get the text. Fast read to string. In path, and that gives a result which can be an error. Should I just unwrap in here? Yep, why not? Okay, and here I can actually parse this. Oh, it's even an option tree. Why? Usage examples. Oh, it just does unwrap and then checks if the good node has an error. Okay. Then why not? Okay. And that should give us the parse tree. And let's do this. We take a twitter node, actually a reference to it, and then what do we do? Okay, this will be a to-do, and here we will call it on the tree root node. Oh, I see. Yeah, nice. Okay, and then what do we do? First of all, let's print I think the debug representation of the node will be fine. Yep, we can see that it's a translation unit. And then for child in node, is it just children? Yeah, children. Oh, and we also need to have a cursor. Whatever. Walk. Do you get it like this? Yeah. Okay, and here, what do you do? a mutable reference to a cursor. Am I right? Yeah, it looks like this. And then let's just print the node of the child. Does it do the trick? Yeah, it kind of does. One nice thing is to add indentation level, which should be 0. Let's add indent size, and let's indent +1. And here let's just print a few spaces. Yeah, and now we can actually see the structure of it. Is it? So we have one function definition, and then it has a primitive type side of it. Well, that's weird. If I remember correctly, there should be more children than just one. So, if I remember correctly, it should have a function declaration should have the primitive type, a type that it returns for void. Then it should have the identifier, then it should have the parameter list declaration, and then it should have the body, but I don't see it here. Why? It's interesting. Okay, let's look at the docs. Translator processing library. No. I want the documentation for the Rust crate. Tree sitter. Okay, so yeah. How do you examine nodes? Okay, so we have a node. Then you can get children. The tree cursor is used to retrieve the children efficiently. Oh, okay, that makes sense. So it recommends not using this children method, but just going through cursor methods, like go to first child. Oh. Okay. What was it called? Current node or just node? Yeah, just the node, which is the current node. Okay, so that's fine. Okay. So what does it tell me? That I should have the cursor, which is like this, and then I replace this with a cursor, mutable reference to the cursor, and here I actually use the cursor. Not this one. Tree cursor. Yeah. Okay. But node. So, and now we can walk the children. And just return. Otherwise, go to no, actually do it like this. So go to next sibling. It returns a bool. If not go to the next sibling, then break. And here print node cursor indent +1. Okay. Yeah, this API is a bit weird. It doesn't feel rusty, but I understand why it's like this. And yeah, here we actually see the full AST of this file. Nice. Now, let's try to generate some reasonable LLVM code from it. Okay, how do we do that? So let's take a look at the LLVM file. So we have to have the source file name here. We have to have the target data layout. I need to read on this. We have to have the target triple. Why does it mention Red Hat here? Interesting. Function attributes. I have no idea what it is, and I think it will be unnecessary anyway. I think this will be unnecessary as well. Did it just ignore everything? Oh, no, this is our function. That's what we need to write. Okay, so let's rename this into test.ll, whatever, and let's generate necessary things. Okay. So instead of printing this, we need to translate it into LLVM IR. How do we do that? I think this will not be as trivial as just recursive function. So, okay, let's have a translator, and let's have an input block for it. Also, I want it to be agnostic to what it translates, agnostic to where it writes. Okay, yeah, let's just do that. So this is our IO, right? Yeah. Okay, now okay, let's do it like this. So how do we initialize it? Okay. Maybe let's not try to encapsulate it right now. So we have the output, R2, and I have a cursor, which is a tree cursor. Okay, now it needs even more parameters, but that's okay. Okay, what do we do now? So we have a instead of this, I do translator, where output is to do, and the cursor comes from here. Actually, I can even do it like this. Tree walk. Then I can translate. What I can do is I can generate the translate method. So what do we have here? Okay, yeah. So what do we use for this? stdio std. . 。  . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 . 。 。 . 。 bound is not satisfied. Is it satisfied for the lock? Oh, it's still not satisfied, so let's do it like this. Let's give it a mutable reference. Oh wow. And if I lock it, no, it's not satisfied. Interesting. So, how do I pass it here? Oh, yeah, I'm stupid. Should be std out. Yep, it doesn't need to be. And tree does not leave long enough. Why? Ah, yeah, that's why. Because it's a temporary expression. So I actually need to have this cursor here. Yeah. Tree does not leave long enough. Why? Yeah, let's read the explanation. Tree dropped here while being borrowed. Binding tree declared here. Temporary with access to the borrow. Yeah, so what's wrong? Yeah, that fixes it. Yeah, it is. Weird. Okay, so now let's translate it. So, slide should return a result. Or something like CR, where CR is or even simpler. Let's just type a string. Debug, clone. Maybe even display. Yeah, FMT, which looks like this. What else? Yeah, this one. Yeah, should have this block. Yes, they are never read. Yeah, that makes sense. Translation does nothing at the moment. So yeah. So first of all, we have self cursor and we have the node. I'll just call it node. Okay, let's translation units, then veil. Fine. Then we go to the first child. If we fail to do that, then okay, yeah, there's nothing we can do anyway. Cannot borrow it as mutable because, yeah. Okay, otherwise, while not while, but yeah, again, the API is weird. So cursor, go to next sibling. If we cannot do that, we break. Otherwise, we do some work here. So, which kind of work? Self cursor node, match node kind. Let's just say to do non node kind in node. So does it, how does it work? No node kind in function definition. Okay, let's make it known. Let's generate it, and it should return a result of error is usually up. And let's say, yeah, let's keep it to do. Does it still work? Maybe let's do another wrap. Not implemented at 66. So here, function definition, right? Okay. What do we need to compile that? So some iteration protocol would be very helpful here. Should I write an iterator for this? I don't want to. Yeah, let's just write it out by hand. So Function definition without children, and let's print it out again. And if everything goes well, again this loop over children, self cursor, go to next sibling, break, let's, it shouldn't be even a loop because we have a fixed number of nodes. Okay, so for the first one should be but yeah, it's useful for debugging right now. So let's do it like this. Function definition. Self cursor node. Let's do it like this. And yeah, so we have the first thing is the type, the return type of the function. Then we have a function declarator, and then we have a compound statement, the body of the function. So let's spell it out. Return type node is self cursor node. If not self cursor, go to next sibling. Oh, that's getting pretty repetitive. What is the next one? Declarator. Let's declarator node self cursor node. If not self cursor, go to next sibling. Yep, that's a lot of details to spell out. Function definition. No. Okay, what comes next? Nobody. That body node is does it make sense to make this a helper? Well, maybe. So cursor go. Let's just do a sanity check that if I can go to the next sibling, then something is terribly wrong. here, let's print it out. To translate, wait, no. Okay. This goes away. Go to next sibling. So what do we do here? If there is a node after the body node, then it's good to know that there is something unforeseen. Definition, expected node. Self cursor node. So now so the best that I can do right now, let's just do it like this. Type node, and let's return. Let's still return to do at the end. This will be declaration node. And this will be body node. Let's see. Yep. So what do we expect as a result of parsing the return type? We expected type. Then we have to dive into the function declarator. And then we have to examine and compile the body. Yeah, so self cursor go to, and we have to go back to the parent. Should this be in the library? Okay, let's not think of that too much. So we have a type. Right now, the only possible thing is void. Okay. First type. Again, let's have a mute self. Let's return a result of a type or C error. And let's keep it to no. Let's change it to return type. First type. So what do we actually do here? Let's take the node. Let's match its kind with. Right now we only know primitive types. It will be a to-do, and any other kind will be SCR. Type. Should it be like this? Yeah, I think it's better to have it like this. Okay, so parse type and. Okay, so how do we parse a primitive type? Can we get the text of the node to as how do we get the text? Node and byte range. What's ID? Ah, it's the AST ID. Okay, kind ID, grammar name, language is extra, named children. What does that even mean? Next named sibling, parent, state range, start byte, start position, to sex. We have 8 text. That's what I want to have. Okay, but it also needs the source. Maybe byte range, range size. Okay, I think I like byte range. So I have to have the source somewhere. That somewhere should be interesting. So I baked the assumption of UTF-8 in here. Okay. Let's just add this to the translator. So we have this translator and we have the source, which is a str. And this should be like this. Yep. Yeah, obviously there are no type nodes, but we can do it like this. And it doesn't implement debug, and that's true. So let's do that. Then get the text of the node. So we have self source, and here we can get the node byte range, and this will be good. And so we have the text match text. If it's void, we are happy. It's okay, type void. Otherwise, anything else, we don't know what it is, so we bail out. Okay, so return type is void. Nice. So we have passed the type. Now let's revisit the declaration. Again, I would say something like function declarator. So what does it return? Something like this. So it has this declaration node. Oh, let's print it out. Whatever, and then let's look around. So of course, go to first child. That's getting old. That's getting old. That's getting really old. Should I have an iterator for this? let's just go ahead. Probably, yeah, you cannot. Nice. And then let's do this in the loop. So of course, you go to next sibling, then break, and here let's node is a self-cursor node, and here we obviously have to go to parent. Here, let's just print it out to look around. Okay, yep, it works. For now. Vehicle node not found. Wait, what? Oh, right. Let's move it over here. Okay, so we have parsed the return type, which is void, and then we have a function declarator, which consists of the identifier and the parameter list. Okay. I should have some kind of indentation going on. Okay, let's not bother with it too much, and let's say that the first one should be the identifier or name node. Then, when we have the name node, we can get the source text for it. That should be something like self source node byte range. Okay, when we have the text of the identifier, oh wow. Which is name node. Then, if everything is well, then we have the text of the node. that becomes the function name. Let's remove this for now. Then let's pass the parameter list. Let's just make sure that it's there. And if we have something else, then we go to the parent. So we have passed the name of the function and we have a parameter list. Good. So now we have to visit the parameter list. Wow, I must say, really hate all of this boilerplate. I think it's time to shave some yaks. Let's call that the public function. Let's call this public function. Let's call this public. I don't know. Anyway. So here we dispatch. That's fine. Here we pass the type. Here we actually want to walk some nodes. Yeah, what I'm thinking about is how to best extract this logic of walking the children. Yeah, it's a really ugly API. Well, not really, but yeah, it's an uncomfortable one. It's the loop, and here, so of course I'll go to next sibling, then return OK. Otherwise, let node soft cursor node. Then we just do node. Then with children or visit children. Again, it's a generic one. Returns something, but that doesn't matter much what. So, and it should take a callback. So, first of all, it tries to go to the first child. If it doesn't happen, oh, interesting. Yeah, it does that unconditionally. So basically, oh, okay, yeah, this API bites again. So if node children count, child count is greater than 0, then what do we do? Self with children, or not with children, but visit children. And here, this print children. Yep, you're right. fn once. and it takes executable self. Okay, in this case what expected children in self-cursor node. We wanted it, but we didn't find any. In the end, we go to the parent. Then we do this loop. Not even the loop, but f of self, and then return result. This is not needed anymore, and this is fine. Yep. Okay. And next child will be something like self option node. That would be something like node. Oh, interesting. Oh wow. I really hate this, but yeah, I do have to have an iterator. Okay, but that should not be too bad for now. Okay, so let's try out this new API. So, self. Visit children. Okay, that should be fine. That should be fine as well. So print children. Yeah, why not? Let's do that. Okay. Parameter list. I really should have the indentation in here. Let's add it here, indent 0. Then I go to translate. Whoa. So of course I go to next first child. Here. +1, self-indent -1. Yeah, maybe let's do okay. To the header. Then +1 and -1. Then no, it's safe, more or less. Checked sub. No, I'm being too pedantic here. Okay, no. Let's go into the function declaration. Yeah, I think too much indents. Let's go here and in 0.2 self-indent print like this. Then we change self-indent +1. After all this happens, we change indent to -1. Okay, function definition. Yep, indent +1, return type. Let's go here. Okay, that's fine. Here we do self indent print. Let's do it like this. Let's do it here as well, oh, shit. Yeah. What do I do here? Function declarator. Where do I go to the function declarator? Here. Self-indent +1. To parent self-indent -1. Do I print anything? Yep, I do. Register 0p. Okay, fine. Then I visit the parameter list again. Do I do indents? Why not? Yeah, again. Let's indent, let's visit children. If we didn't went at the first child, then nothing. If we went, then +1, self-indent -1, and then in the callback, what do we do? Here also. Okay. And when we visit children, we increase indent again. Okay, that should be pretty good. Okay, function declarator. Why does it not print itself? Interesting. Where do I visit function declarator? Ah, here. And yeah, obviously I don't do indentation here. Okay. First child. Yep. Nice. Really nice. Okay, so function declarator here, function declarator name test, parameter list here. Nice. Okay. Parameter list. Where's the children? Okay, now instead of this, let's do so what do we do here? Next child. Okay, yeah, that's fine. Okay, or else let's do a nice thing, which should be like this. Oh, from string maybe, yeah. From. Why do I have to spell this crap? Okay, now primitive type text, whatever. Yep. Okay, or else what? Or else format. Let's even use it on list. Okay. Wow, it even works. Open. Okay, let's do something like expect child text. Str. Here and oh, nice. So actually, self cursor node, self cursor, go to next. Oh shit! How do you know? Come on. Okay. I don't. Okay, yeah. I think it will be fine. Then that's not how to do it. Yeah, you do have to do it fine. And if you do have some node, if this text node oh, even better, node kind. Oh, even better. Node kind is not the expected kind. Yeah, it's CR format. What do we do here? Expected. Kind found node. And yep, this was a bit too much. Okay, node. Next, okay, node. Yep, why not? This is not needed right now. Okay. Yep. Can even do it like this and discard the node. Struct. Oh, right. Short kind. Okay, what do we do here? If, yeah, that goes out of the window. No, it does not. If node kind is equal to the closing bracket, then return. Okay. Otherwise, to self-indent. Oh, this code is getting really repetitive. To do parameter. Which one? Node. CR. And format to do parameter like this. So, what's wrong with you? Borrow checker is not happy because immutable borrow later immutable borrow occurs here with children But oh, did I use self? Yeah, I should not have used self. This. Ah, it was beautifully burned. So what? Oh, does it think? Okay, yeah, I need to correct this. And I also need to correct it here. And that gets rid of that error. Nice. So function parameter list, and there was nothing in the parameter list, I guess. That's fine. And then we go into the body, the compound statement. Okay. Oh, it's time to actually produce something. So let's take a look. So we have to emit the source file name. Yeah, let's emit the source file name. Wow, it's a bit dirty, but let's clean it up later. Out path. Yeah, maybe it will fail. That's fine. Now yeah, I cannot say I like this. That's fine. Okay. So this will be the out, like this. What we can do here, right into out, right, source, what was it? Source file name. And that is to have a quote in, and that will be in pass as str. Well, actually, let's do it like this. Cannot write. Cannot write. Why? Oh, yeah, this trait is in scope, so I do have to use write. Does that help? Cannot borrow is mutable. Does that help? Used result. Wow. What else? Triple data layout. Whatever. Right line out, and let's just use it. No, it's wrapping it, okay. And then let's write out target triple. And target triple will be this one. I really don't like this red hat part. So yeah, maybe let's change it like this. Okay. Not yet implemented. 119. Yeah, that's true. Okay. Body. Interesting. Oh, it prints. Wow. Wow. Expected top level entity and target triple is not at well. Oh yeah. Target. This syntax is a bit weird. TMP. Test.io. Okay. Okay. That sounds sensible so far, because we still don't output the function itself. And that should be to structured data out and print display it here. Okay, to don't hard code it. Triple. We're getting somewhere. Wow. Output the header. This is not needed anymore. And okay, that's fine. I don't need this function definition. Ooh. Wow. So should I make this children? This goes away. This goes away. Here, what happens here? I can still modify it directly. So what's wrong here? Oh, yeah, makes sense. Oh, please just stop. This, I replace self with this. And now it should be fine. Yep. Okay, that's fine. Or no? Yeah. So the function. Function definition. I know the return type. Well. So we have body node in here. Right. Define. Where to self out. That's there. We have to strain and convert back. No. Oh, not self. Yeah, this. That works. Good. Right. Get this out. Fine. Then the representation of the type. name of the function. That's true. The positional arguments, the first one is return type, the second one is where do I get the text? Declarator. Oh. Well, interesting. I do nothing with it, okay. Then I evoke parameter list and do nothing again. I think it's fine. Fine-ish. Okay, I give up. Let's do it in the stupid way. This out, declare, return type, wrap, I'll do that later. Function declarator, what do I do? So, function declarator, okay. What is all of this? Expects child kind, which one? Oh. Yeah, that's fine. That's fine. Oh shit, parameter list. Oh. does function declarator look like? Name. Right. Parameters. I think it's fine to just do it here right now. Oh. Let's do it like this. Oh, no. Where to self out. And then yep, that's true. Not found. Type annotations needed. What? Expected function found result. Thank you so much. Type annotations needed. Yeah, that's true. So, where did I print this out? Did I do that in function declarator? Yes, I did. Why is it so unpleasant? Function declarator. So let's try to do it well. the result becomes a string and something the kind of the parameter list. And params, where params are the result of parameter list, and parameter list becomes vector of I don't really know what. Param okay, let's say this becomes string and a vector of param. You cannot, yeah, that's true. Okay, I cannot find. Function is never used. Variable does not need to be mutable. It will need to be mutable, and test.ll declare void. And here it becomes interesting. So function definition, right? Yeah. Type. Name. Params. What did I just do? Okay. Wait, like this. This. Compile the body. out. Expected variable entity, which is it's not declare, it's define. Define return type which body requires at least one basic block, which is good. Whoa! So what happens now? Error expected type. Right, what? Yeah. Return type. Now it cannot borrow. Right? Test.ll. Whoa! Now we're getting somewhere. Interesting. Let's say we have something like main C. It has main. It has something like test. Let's say this. Let's say compile main C to main O, and let's say we have test.o db main test address boundary error. Why? Yeah, maybe that's why. Test.o db main C. Okay, it calls it. One more thing. How do I generate this main stop? Maybe better decision is to have defined functions. Oh, do I really want to go there? Maybe. So, if I have a main C, what would it look like? It would look like this. Here we could actually get main. I need to compile this. TMP main C. Primitive type int. makes sense. Kind of makes sense. Int. But so far it's fine. And where do we browse the type here? And that's fine. Will it compile? Yes, it compiles. It fucking compiles. Wow. And so here it should generate what it returns. This only works for void. But if it's a main, it should return zero. Int 0. Yeah, fine. Case we add implicit return 0. That should look like red 532. Will it even compile? Clunk. Main.ll. Main. It returns. Does it actually do what I think it does? Oh, yeah. run c t main ll. Doesn't do shit. So 42. Yep. I compiled my first main function. It works.